College Trigonometry, Chapter 8, Section 5, Functions of Angles and Fundamental Identities. Okay, so far we've dealt with angles that have been placed on the unit circle. Remember that on the unit circle, we decided that the cosine of theta, the angle is x, and the sine of theta is y. And these relationships assume that you're dealing with a unit circle, which is a circle of radius 1. So what we're going to do now is say, well, what if they are just, the points are placed anywhere on the plane? They're not a radius of 1 away from 0, 0. Now to define the 6 trigonometric functions, we're going to start with an angle theta in standard position. And we're going to choose any point P having coordinates on xy on the terminal side, as you see here. So we've got our angle theta, and it's in the standard position, and then we have our terminal side that goes through point P. Point P has coordinates xy. Notice what we've done is we have dropped a vertical line from point P to the x-axis, and we've created a right triangle. And one side of that is going to be x, and the other side of that triangle is going to be y. The distance from the origin to the point is our radius of our circle, but it's also the hypotenuse of that triangle. So using the Pythagorean theorem, we have that x squared plus y squared equals r squared, and or you can use the distance formula, which is based on the Pythagorean theorem. But either way, we end up with the distance r is going to be the square root of x squared plus y squared. Also notice that r is going to be greater than 0 because distances are never negative. Now our x could be negative and our y could be negative, but when we square them, that will become positive. The 6 trigonometric functions, as we've said before, are sine, cosine, tangent, cotangent, secant, and cosecant. So let xy be a point other than the origin on the terminal side of an angle theta in standard position. We just showed that the distance from the point to the origin is the square root of x squared plus y squared and is represented by the letter r. The 6 trigonometric functions of the angles will be as follows. The sine will be y over r. Now before it was just y because remember sine is opposite over hypotenuse. The hypotenuse was a unit circle, it was 1. Now it's not necessarily 1, so r is representing that distance for that hypotenuse. Cosine is x over r. Tangent hasn't changed, it's y over x. It never depended on r to begin with. And then you see the reciprocals, cosecant, secant, and cotangent. Okay, now let's do this example. The terminal side of angle theta in standard position goes through -3, -4. Find the values of the 6 trigonometric functions of theta. Pause the recording, give this a try, and resume to check your answer. You most certainly can draw this on a graph and use that to help you, use the triangle to help you find r, or you can use the fact that we said that r is the square root of x squared plus y squared. So r is going to be -3 squared plus -4 squared, which is 9 plus 16, so the square root of 25, which is 5. And so we have that the sine is -4/5, the cosine -3/5, the tangent 4/3, and then you see we took the reciprocals for the others. Be careful, notice the little word here, use parentheses around substituted values to avoid errors, and that's important especially if you're doing this in your calculator. So the 6 trigonometric functions can be found from any point on a line because we have similar triangles. So it doesn't matter whether the point is at the end of a radius of 1 or if it's way out there, because we can draw similar triangles as you see here. We have a point that's close to the origin and the point that's farther away, and we have 2 similar triangles. And even though the measurements of those, the radius, the measurements of the hypotenuse are not the same, they are in proportion, and trig functions are proportions. That's what they are. So everything is going to stay the same even if the point is farther away down the line. So the sine of y over r is going to be the same no matter what point on that line is used to find it. So you could use any point on that line to find the sine of that angle or the cosine or any of the 6 trig functions. We can also find the trig functions using the values for the values of an angle if we know the equation of the line that forms the terminal side. The line itself will go through the origin, and the problem you're doing will indicate whether you should use positive or negative x values on that line, because you need to know which part of the line to use. So what you're going to do is you're going to choose a point on the part of the line that's indicated, and then you'll use what we've been doing to determine the trig. So we're going to find the 6 trig function values for the angle theta in standard position if the terminal side of theta has the equation x plus 2y equals 0. So there's the equation of the line for the terminal side, and we're only going to draw that line for numbers for x that are greater than or equal to 0. Just pause the recording, give this a try, and resume to check your answer. So we have a picture here of the line, and we're only using, again, positive values for x, or 0. And you can use any point on that line except the origin. You just can't use 0, 0 to help you find the equation. Now, in the example here, they chose x equals 2, which means y equals -1. You could have used a completely different point. It doesn't matter, because when we put them into the ratios, remember, everything's in proportion, the ratios will be. So we have the point 2, -1. Using our formula for r, we get square root of 5. And then solving, we have y over r is -1 over square root of 5. We want to rationalize that denominator, so we'll multiply the top and bottom by the square root of 5 and get negative square root of 5 over 5. Do the same for cosine, only it'll be 2 over square root of 5. And then tangent is going to be y over x, so it's just going to be -1/2. And then do the reciprocals. For the reciprocals, you can actually go back to what you got before you rationalize the denominator. Find the values of the 6 trig functions for each angle if possible. So you're going to do an angle of 90 degrees and an angle in standard position with a terminal side through -3, 0. Pause the recording, give this a try, and resume to check your answer. Okay, you can't really draw a triangle with a 90-degree angle, so drawing an illustration might not help with this one. However, x is 0, y is 1, so r is the square root of 0 squared plus 1 squared, which is 1. And then what we're going to do is use those to write our ratios. So you see here the sine, the cosine, the tangent, which is undefined, the cosecant, the secant, which is undefined, and the cotangent. So for part B, we're going to do something very similar. Again, illustration is not that helpful. You can't draw a triangle with this. However, we know that x is -3 and y is 0. So we can calculate that r is 3 and then create our ratios. And you can see them there. So undefined function values. If the terminal side of a quadrantal angle lies along the y-axis, then the tangent and secant are undefined, and if it lies along the x-axis, the cotangent and the cosecant functions will be undefined. Remember, the reason for that is that when it's along the y-axis, x is 0. X is in the denominator of tangent and secant. If it lies along the x-axis, that means the y is 0, and the y is in the denominator for cotangent and cosecant. It's a chart of those values, and you should become very familiar with them. They've got the angles in degrees here. Of course, remember, for radians, it would be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, just a reminder about reciprocal identities. We know that the sine of theta is y over r, and the cosecant is r over y. We know that the sine is 1 over cosecant, and cosecant is 1 over sine. These are just the reciprocal identities spelled out for us. We've seen them before. We've actually used them. Just kind of summarizing them here one more time. And these are fine as long as we don't have a 0 denominator. When we have a 0 denominator, then our value is going to be undefined. So we're going to find the sine if the cosecant is negative square root of 12 over 2. Pause the recording, give this a try, and resume to check your answer. All right, well, sine is 1 over cosecant, so we have 1 over the square root of 12 over 2. Little error there in the notation that 2 should not be included under the square root symbol. And then what they did was they just kind of did a keep, change, flip on that, simplified it. We have negative 2 over the square root of 12. Then they simplified the square root of 12. Remember, break that down. The square root of 12 is 4 times 3. 2 times 2 times 3, so the 2's are paired and they get to come out. So we have negative 2 over 2 square root of 3, which is negative 1 over the square root of 3. And then rationalizing, finally we get negative square root of 3 over 3. So in the definitions, our distance r is never negative. Our r is always positive. It's always greater than 0. Choose a point in quadrant 1. Both x and y will be positive, so the values of the 6 trig functions will be positive. Quadrant 2, x is less than 0, y is greater, so sine and cosecant are positive. Everything else is negative. And we've talked about this before, so you know how the quadrant gives you an indication of the sign of the function. Just a review of that. What is positive where? This is very handy to be familiar with it. And notice in all cases, r is greater than 0. All right, so try this example. You're going to identify the quadrant or quadrants of any angle theta that satisfy sine is greater than 0, tangent is less than 0. Pause this recording, give it a try, and resume to check your answer. Okay, this is kind of using the chart, but we've done these before in a couple sections ago. The sign is positive only in quadrants 1 and 2. Sign is negative in 2 and 4. So it must be quadrant 2 because that's the only quadrant that satisfies both of those conditions. Okay, now what we're showing here is it's kind of like taking an angle and opening it up. So in the first figure, you've got a small theta, and then we increase it and increase it and increase it. So we're increasing the angle from 0 to 90. Notice that the y value increases, but the y value is never greater than r. So y is always going to be less than or equal to r. Because remember, r is the hypotenuse. It's always the longest side. So until we get to 90-degree angle, y is always going to be less than r. Dividing both sides by r, so we have y is less than or equal to r. If we divide both of those sides by r, we get y over r is less than or equal to 1. And we can do the same thing in quadrant 4, do a similar analysis, and we find that negative 1 is less than or equal to y over r. So negative 1 is less than or equal to y over r, which is less than or equal to 1. Well, remember, y over r is sine. So that tells us that the sign has to be between negative 1 and 1. Now, we already knew that. This is just giving you another indication, kind of a solid evidence as to why. And we could, by similar methods, show that the cosine has to be between negative 1 and 1. Now, because secant and cosecant are reciprocals of sine and cosine, that means that the secant is going to be less than or equal to negative 1 or greater than or equal to positive 1. And the same for the cosecant. It's either going to be less than or equal to negative 1 or greater than or equal to positive 1. And we've seen that with the graph. Here's a summary of the ranges of our trig functions. Okay, we've already said that sine, cosine have to be between negative 1 and 1. Tangent and cotangent we've seen go from negative infinity to positive infinity, so all real numbers. And then secant and cosecant are going to go from negative infinity to 1, and then from 1 to infinity. All right, so we're going to decide whether each statement is possible or impossible. So pause the recording, look at the statement that it's given you, and just ask yourself, can these be true? If they can, then it's possible. If they can't, it's impossible. Pause the recording, give it a try, and resume to check your answer. Okay, first of all, the sine of an angle cannot be the square root of 3 because the square root of 3 is greater than 1, and sine cannot go above 1. The tangent of an angle can be 110.47 because the range of a tangent is all real numbers. The secant of an angle cannot be 0.6 because it cannot be between negative 1 and 1. It's either going to be less than negative 1 or greater than 1. We've really already looked at these identities. This is demonstrating that they're valid even when we're not dealing with a unit circle. So we've got a circle of radius r, so x squared plus y squared equals r squared. If we divide everything by r squared, we get x over r squared plus y over r squared equals 1. Well, cosine is x over r, sine is y over r. So this just kind of proves that Pythagorean identity of sine squared plus cosine squared equals 1. If we take this and we divide everything by x squared, then we get our identity that 1 plus tangent squared equals secant squared. And if we were to go back to the original divide everything by y squared, we would get 1 plus cotangent squared equals cosecant squared of theta. So it doesn't matter the fact that we've moved the point away from having to be a part of the unit circle. These identities are still going to hold true. Review of the Pythagorean identities that we've already seen and used. Again, remember, these are not on your formula sheet, so you want to be very familiar with these. These are extremely helpful identities and will continue to be useful throughout this course. Now, we've seen these identities also. These are the quotient identities. We've said that sine is y over r and cosine is x over r. And we're going to consider the quotient of sine and cosine. So if we put sine over cosine, we get y over r over x over r, which reduces to y over x, which is the same as tangent. So again, this is just redemonstrating that the tangent does indeed equal the sine over the cosine, and the cotangent is also represented by the ratio of cosine over sine. Okay, now let's use some of these identities. We're going to find the sine and the cosine if the tangent is 4/3 and is in quadrant 3. Pause the recording, give this a try. Again, you're going to be using some identities, and then resume to check your answer. All right, since the angle is in quadrant 3, that tells us sine and cosine will both be negative. We know that 1 plus the tangent squared equals the secant squared. So 1 plus 4/3 squared equals secant squared. 1 plus 4/3 squared is going to give us that the secant is negative 5/3. Now, why do we go with negative? Again, it said it's in quadrant 3. So when we simplify 1 plus 4/3 squared, 1 plus 16/9, and we take the square root, we're going to go with the negative square root because, again, this is in quadrant 3 where cosine and secant will both be negative. So the secant is going to be negative 5/3, which means the cosine is going to be 3/5. And then we can use our other Pythagorean identity, sine squared plus cosine squared equals 1, or they actually flipped it around here. What they did was they subtracted the cosine squared from both sides and put in the negative 3/5, and we find, again, that the sine squared is 16/25, but it's in quadrant 3. So when we take the square root, go with the negative square root, it'll be negative 4/5. This is additional practice. So as you go through these, try the problems out, pause the recording to try them, resume when you're ready to check your answer, and continue this way through the rest of the recording.